Here's a critical points question. We first have to find the critical point, meaning that you have to calculate the gradients. Gradients are simply a vector made of all possible partial derivatives. Because this is a function of x and y, I wrote f differentiated by x, f differentiated by y. Okay? What is that? Well, if I differentiate this by x, x turns into 1. Derivative of x is 1. X cubed is going to give you, 3 comes down, right? So 3 times 9 is 27, x squared. And then y squared is considered as a constant. Therefore, when you differentiate this by x, that's considered a constant, so it's 0. That's all you get. Now let's differentiate by y. If I differentiate this by y, I get 12x. Differentiating this by y gives you 0 because x cubed is considered as a constant, and this one minus 16y. And because I need gradient of f to be 0 in order to get a critical point, I see that 12y minus 27x squared has to be 0, and also 12x minus 16y has to be 0. Another system of equations. Both need to be satisfied in order to be called a critical point. Let's try to solve the second one by y. If I solve for x, then I have to square it, so it becomes harder. So let's solve this by y. So 12x is equal to 16y. Let's first divide it both sides by 4 because that makes it easier. So it becomes 3x equals to 4y. Therefore, y becomes 3/4 of x. Okay. Now plug that in here and see what we get. That's 12 times 3/4 of x minus 27x squared equal to 0. And then 12 divided by 4 is 3, and then 3 times 3 is 9, so that becomes 9x minus 27x squared equals to 0. This time I can divide both sides by 9 to make it simpler before doing anything. So that's what you get. And because this is a quadratic equation, you have to factor it, or you can also use quadratic formula, but that's an overkill. This is easy to factor. X is a common factor to both. So let's factor out an x, which means either x is 0 or 1 minus 3x is 0. X is 0 is x equal to 0. This one I can move 3x to the side, divide by 3, so you get 1/3. So you have two possibilities, okay? So you have case 1, when x is 0. Now if x is 0, then because y is 3/4 of x, that's also going to be 0, which means that the critical point is 0, 0. Now we have to figure out whether we have a relative max or min or saddle at 0, 0. And to do that, we need to calculate the Hessian. Okay, so what's the Hessian? Well, I have to take this and differentiate by x. So if I differentiate this by x, you get 0. If I differentiate this by x, I get negative 54x. Okay. But then in the second one, I have to differentiate this by y, so I get just 12. Now, if I were more careful, then I would also differentiate this by x to see that you get 12, and indeed they're the same. Okay. Yeah, but you can just say, oh, these two are the same, so I just put 12 there. And then this, because this is fyy, and Hessian is fxx, fxy, fyx, and fyy. Here goes the derivative of this thing by y, which is negative 16. Okay. Now that's a huge number. What's 16 times 54? Anyone help me? 1630.
Uh, 864.
Huh?
864.
Okay, thank you. 864. 144. Yeah, I tried to be faster than your calculators, but I failed. It's a bit hard. Okay. All right, so that's what we have. Okay. And therefore, what we have is that Hessian at 0, 0, which means x and y are both 0, right? So the value of the Hessian at 0, 0 is a64 times 0 minus 144, which is negative 144, which is negative. Okay, what does that mean? If the Hessian is negative, that means it's a saddle, right? If Hessian is negative, that means that Hessian matrix has two eigenvalues of negative signs, okay? It means that as you go 360 degrees trying to do the second derivative, at some point there will be positive smiley, at some point there will be a negative in the perpendicular direction, and then you that means it's a saddle, okay? Because one direction is like the maximum, but in the other direction it's like the minimum. So it's a saddle, okay? So that means 0, 0 is saddle. Okay. Case 2. Well, x could also be 1/3, right? Now, what does that mean? That means y, since y is 3/4 of x, and x is 1/3, 3 cancels, and you get 1/4. So we're talking about the point 1/3, 1/4. This is the critical point that we're interested in. And in that case, h at 1/3, 1/4 is going to be a64 times 1/3 minus 144. Let's see, what's that? 27, 28, 4, 4, 8. That's 288 minus 144, which is 144. Okay, so this gives you 144, which is positive. Am I right? Yeah, yes. All right, and then you can also see that fxx at 1/3, 1/4 is negative 54 of 1/3. See, this part is fxx, right? And then you have to plug in 1/3 into x and 1/4 into y. So when you plug in 1/3 into x, that's equals to negative 18, right? Which is negative. Okay, so what does that mean? Well, this one says in the x direction, the second derivative is negative, so it's a frowning face, right? Which is a relative max, right? But then Hessian is positive. What does that mean? That means once negative, it's always negative. So going all the way around 360 degrees at this point 1/3, 1/4, it's always a frowning face. Okay? What does that mean? Therefore, 1/3, 1/4 is a relative what? Max. Yeah. That's how you do it.